In the winter of 2019, the American Midwest and Northeast turned into a real-life disaster movie. I'm talking about that time when temperatures dropped to negative 63 degrees Fahrenheit. There were massive flight cancellations and power outages, dozens of injured people, and shut down schools and offices. Simply going outside became highly risky. And if you're looking for someone to blame for all this, I've got two words for you: polar vortex. That's not some scary storm, but a huge mass of cold air that's normally spinning counterclockwise around the poles. When it's summer up in the northern hemisphere, the vortex stays further north, and in the winter, it heads south a bit. The term polar vortex has been around since the late 1940s. It shows up every winter and calls it quits in the spring. But for about the last 20 years, this polar vortex has been acting weird in the middle of winter. It looks like it either splits or becomes displaced once every other year. At the bottom of this vortex is what they call the polar front, or the polar jet stream. This jet stream moves from west to east, which is why places like the northeastern part of North America get hammered by that chilly polar vortex weather.
Ooh.
These jet streams zip along because of differences in temperature and the Earth's spin. When there's a big gap in temperatures, the winds really pick up speed. In spots like the equator, where the sun's rays are more intense, the air heats up and starts to rise. And as it goes up, it leaves behind a sort of empty space, taking in air from all around, kind of like a huge vacuum cleaner. But over at the poles, where it's way chillier, the air shrinks and sinks, forming areas of high pressure. It's like a bunch of air molecules trying to spread out, like a group of school kids on a big field. So you've got these two forces at play: warm air rising and cold air sinking. Air wants to zoom from the poles down to the equator with this setup. The jet streams tend to hang out where airplanes fly, about 30,000 feet in the air. Pilots often use them to zoom across the sky faster and save some fuel. But these jet streams aren't always the good guys, as they can bring all sorts of weather changes, like cold snaps and heat waves. When the polar jet stream is strong and cruising at about the same level as the vortex, it kind of locks in that cold Arctic air within the Arctic Circle. Every now and then, the jet stream takes a chill pill and starts moving around the planet in a wavy pattern called Arctic oscillations. This creates peaks and troughs that allow warmer air from down south to head north, and the chilly Arctic air to take a trip south. In the northern hemisphere, there are two polar vortexes, one in the lower atmosphere known as the troposphere, and another higher up in the stratosphere. The stratospheric vortex forms as cold, dense air sinks and twirls near the North Pole. The mightier the vortex, the quicker it spins, keeping cold air locked over the high latitudes. When someone or something messes with the polar vortex, it goes haywire. Picture a spinning top. Give the table a shake and it'll start wobbling. When the polar vortex loses strength, it can't corral the cold air anymore. So, blasts of icy Arctic air surge southward over North America. The polar vortex isn't a fixed object, but more like a living being. It gets stirred up by ripples on Earth's surface, triggered by stuff like air flowing over mountains or across land and sea, all warming up differently. If our planet were as smooth as glass, with oceans wrapping all around, the polar vortex would just chill out, never breaking up. But every time a wave smacks into it, it gives the vortex a push. Sometimes, one of these waves packs enough punch to shove the vortex off the pole or even spin it in reverse. And when that happens, the temperature in the polar stratosphere can skyrocket by a whopping 50 degrees in just a week. The Arctic's polar vortex started spinning in the opposite direction in March 2024 and got scientists worried. It's one of the 6 strongest flips since the 70s. This time around, it hasn't caused any chaos. Sometimes the waves of air affecting the vortex get strong enough to split it into 2 parts, kind of like how a cell divides. They're called daughter vortices, and they even add more chaos to the mix. When the vortex splits, one chunk usually heads over Siberia, while the other cruises over North America. Once that split goes down, the jet stream in the troposphere above the Atlantic decides to take a southern vacation. That jet stream usually acts like a bouncer, keeping the chilly Arctic air up near the pole. But when it heads south, that Arctic air gets a green light to crash the party in places like the East Coast, the Midwest, and even Western Europe. The storms that usually ride along with the jet stream follow along and head south too. They take their time to get organized and catch up with the new path of the jet. So, instead of hitting up Canada like they usually do, they swing by New York and Chicago for a change of scenery. Scientists still don't know why the polar vortex doesn't mess with the U.S. Pacific coast. It might have something to do with where the jet streams hang out in each basin. Over in the Atlantic, the jet stream kicks it at higher latitudes, while in the Pacific, it's chilling closer to the equator. It might also have to do with the landscape. In the Atlantic, the air has zipped over the Rocky Mountains, stirring up waves off tall peaks that mess with the jet stream. But in the Pacific, the jet stream is away from any big mountains that could cause trouble. The recent reversal of the polar vortex is unlikely to make the temperatures drop extremely, but scientists aren't sure what's going to happen to the polar jet stream in the future. They're concerned that the chilly polar air might make more trips down to the mid-latitudes and bring along more chilly spells in the long run. So it's better to be prepared. When the news tells you there's a huge winter storm coming and power outages are highly likely, fill your bathtub with water. If you have an electric water pump, it won't work and you'll run out of water soon. Gas stations also run on electricity, so fill your car tank before the storm hits to have some emergency gas. When the storm arrives and you're locked in, put on several layers of warm clothes, thermal wear, a warm shirt, a sweater, and insulated pants and woolen socks. Don't forget mittens so the heat doesn't escape through your hands. Hang dark blankets on your windows to draw in heat. Make sure your doors and windows are closed well, and put some towels under them to prevent drafts. Your basement is probably more insulated by the ground, so it could be a good place to spend the night. To warm up the cold winter bed in your home, fill a bottle with hot water and place it in your core region under the cover. The water will heat up your vital fluids traveling through your body, reaching all the extremities and warming you up in no time. You can also wrap your pajamas around the bottle before putting them on for an extra effect. When the power comes back on, check all your appliances and electronics before turning on the main power switch. They must be unplugged to avoid power surge damage. As you turn the water supply back on, keep the taps on the lowest level of your house closed to let the air out from the upper taps.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside, they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes.
It was in the year 2014 when a satellite snapped a picture of something unusual in the middle of the Pacific Ocean. It was a giant, almost perfect ring floating all by itself. It was an eerie sight. This formation showed up thousands of miles southwest of Hawaii and was about 280 miles wide. Who created this ring? How did it appear there? The questions were countless. The huge ring was spotted by NASA's Terra satellite with the help of a special camera called MODIS. Later, after examining the images, scientists realized that the ring was made out of perfectly shaped clouds. Even though clouds like this aren't super rare, it's not common to see one that big and completely on its own. Normally, such clouds show up in groups, not just hanging out solo in the middle of nowhere. The ring is made of puffy cumulus clouds. It turned out that it had been shaped by something called a Rayleigh-Bernard convection cell. It's a fancy schmancy way of saying that the clouds formed when warm air rose and cooler air sank, creating a circular pattern. Now, there are two types of such cloud cells. One is a closed cell, where cold air sinks around the edges and clouds pop up in the middle. The other is an open cell, where cold air sinks in the center and clouds form around the outside. And that giant ring floating over the ocean was exactly a closed cell, hence its cool shape. Interestingly, such cloud patterns usually look like a bunch of hexagons packed together, like a beehive in the sky. But this one was out there all by itself, which made it even more eye-catching. Now let's take a look at how the ring's formation happened in detail, shall we? At one point, the sun heated up the water or land, warming the air above it. That warm air got lighter and started rising. Cumulus clouds formed. Maybe it even rained a bit. When that rain came down, it cooled the air beneath the clouds. That cooler air then sank and spread out in all directions. But when it ran into the surrounding warmer air, it pushed the warm air upward again. That's how the ring of clouds formed around the original spot. This whole thing happened just south of the Intertropical Convergence Zone, a region near the equator where trade winds meet and often cause thunderstorms and heavy rain. That particular location probably helped with the formation of this cool cloud pattern too. Now, take a look at the right side of the satellite image. The ocean looks super shiny there, almost like silver. That shiny effect is called sunglint. It happens when sunlight reflects directly off the ocean's surface and hits a satellite camera just right. It kind of turns the sea into a ginormous swirling mirror. The cool thing is that the texture of the water, whether it's smooth or choppy, changes how that sunglint looks. Most of the time, the wind stirs up the surface, creating waves. These waves normally scatter the sunlight in different directions. But some of that light still hits the satellite, so the area looks shiny. But sometimes, if the water is super calm or there's a break in the wave pattern, it can create darker patches where less light gets reflected back. It gives sunglint zones a strange, patchy look. So if you notice really dark spots in satellite images, keep in mind that they might not be shadows or oil spills. Most likely, they're just signs of how the wind and waves are behaving on the surface of the ocean. Now, at the same time, it's not just weak winds that can smooth out the water. According to an oceanography professor from the University of South Florida, other stuff like freshwater, ship wakes, and even natural ocean movement, such as underwater waves or currents, can change the water's texture too. And all these phenomena can mess with how the sunlight reflects, which, in turn, can cause weird patterns in the images. Some of the darker lines you can see, for example, inside places like Delaware Bay or Chesapeake Bay, might be freshwater mixed with things like algae, dissolved plant material, or even natural oils. But those patches aren't usually as big as the giant dark blob they saw off Delmarva. It happened on May 6, 2023, when the ocean just east of the Delmarva Peninsula was super calm. There was barely any wind. So the surface of the water was all smooth and glassy like a giant mirror, and the angle was just right to make it look dark. Now, even though these sunglint effects make for some stunning satellite pictures, they can be annoying for scientists who are trying to study the color of the ocean or track things like phytoplankton blooms. Basically, sunglint can cover up the stuff they actually want to see. So, to work around that, scientists and engineers have built tools to either fix the data afterward or design sensors that avoid the glare in the first place. For example, the new Ocean Color instrument on NASA's upcoming PACE mission is designed to tilt just enough to dodge the worst of the sun's reflection. Oh, by the way, NASA scientist Ralph Kahn reminds us that our eyes can deceive us, judging brightness based on what's around it. So even a dark patch in an image might actually be pretty bright. It just looks dark compared to the shiny parts nearby. Now, let's tilt our heads back to the night sky. See that weird glowing spiral? Looks pretty extraterrestrial, doesn't it? Well, chances are it was just a SpaceX Falcon 9 rocket doing its thing. When these rockets launch satellites into orbit, they sometimes dump leftover fuel once they're high up in the atmosphere. That fuel freezes and starts spinning around as the rocket moves. It looks like a mini ice tornado in space. But what makes it look even crazier is sunlight. Even if it's dark where you are, the rocket's way up high where the sun can still hit it. The light reflects off the icy fuel spiral, making it glow. Just a bit of night sky drama, but nothing mysterious. Now, let's admit it, you aren't likely to see a real-life flying saucer. What you can see, though, is a lenticular cloud, which looks pretty much the same if you ask me. These clouds pop up high in the sky, usually around mountains, where moist air flows over them just right. Even though the wind is moving super fast, these clouds just kind of hang there, totally still, like someone has parked them there. They're usually perfectly shaped, smooth, and saucer-like. And still, it's just nature showing off again.
3, 2, 1.
Another kind of weird stuff you might see in the sky is space junk. When satellites stop working, a lot of them are just left behind, floating around. Eventually, they slow down because of atmospheric drag and start falling back to Earth. When they do, they light up the sky like massive fireballs. Sometimes it can last for nearly a minute. As the pieces burn up, the different materials they contain can create colorful streaks in the sky. And once in a while, chunks actually survive the trip and crash land on Earth. The leftover bits are often twisted and scorched, and they look so strange that people sometimes think they're wreckage of spaceships from another planet. But nope, just another piece of our own space clutter coming home. Now, look at this. A plane is flying straight toward the horizon and leaving behind a long contrail. You know, that artificial cloud from engine exhaust? And in some cases, it can look like something is falling from the sky. The wind can blow those trails wider, making the whole picture seem even more dramatic, because it looks like smoke from a crashing object. Add in the red glow from a setting sun and, well, it looks like something is on fire and plummeting to Earth. Plus, if sunlight reflects off the bottom of the plane just right, it can look like there's a glowing core in the crashing cloud. But the giveaway is the speed – slow. Real falling objects, especially from space, zip across the sky at thousands of miles per hour. So if it's barely moving, it's probably just a plane. Nothing to worry about. Wink wink. Ah, a purple sunset. You must have seen one of those at least once in your life. Normally, it's nothing ominous and has to do with the way light travels. The light that the sun produces is white. When it goes through a prism, you see light waves of different colors, from red and orange to blue, green, and indigo. Light normally travels in a straight line if there's no obstacle in its way. The shorter light waves, including blues and purples, are scattered easier when they meet with those obstacles, like molecules and aerosols in the atmosphere. Because the sun is low on the horizon at sunset and sunrise, its light has to pass through more molecules that scatter the violet and blue light. The colors that your eyes pick up, then, are yellow, orange, and red. But with the right conditions, you can see the gorgeous purple sky. Sometimes purple sky appears for much scarier reasons. It can be caused by hurricanes, wildfires, or dust storms. The concentration of vapor in the air increases, and the light scatters more than usual. Dust, a setting sun, and low cloud cover all contribute to this natural show, too. The sky turns orange and red at dusk if there's still enough light. Then it gives off pink hues, which mix up with a dark blue sky above. Now, do you remember what happens when you mix pink and blue? You get the color purple. Not every hurricane makes the sky turn purple, and trying to predict if it's going to happen is like trying to forecast a rainbow. Still, people reported several major hurricanes made the skies turn purple. Now, green skies might look just as spectacular as purple ones, but they actually also scream danger. They're usually there to tell you a thunderstorm, hailstorm, or a tornado is somewhere nearby. The unique color is a result of yellow sun rays getting mixed with the blue light coming from storm clouds. So you're enjoying a nice day by the ocean with a fresh breeze in your hair, when suddenly you notice the water starts retreating from the beach at a huge speed. This is a sign for you to start running as fast and far away from the beach as you can. This most likely means that a tsunami is on the way. A quick reaction maximizes your chances of survival. Now, if you notice the sea level is rising, but it doesn't seem too extreme, it could be another sign of an approaching tsunami. It happens in 40% of cases, and the incoming water is the first tsunami wave. The next one, way larger and more dangerous, usually follows in about 10 minutes. Another thing about tsunamis is that they like to arrive with some loud sounds. People describe them as thunder, the sound of a locomotive, a helicopter, or just a loud boom. Do you see a channel of choppy water on the beach? It's in your best interest to stay away from the water. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange break in the waves, or an area with a different color than the rest of the water. Random bits of seaweed going in all directions is another rip current warning sign. If you happen to find yourself caught in a rip current, try to stay afloat, but don't try to go against the current. You'll only waste precious energy. Scream for help and try to float your way along the beach. Once you break out of the current, swim diagonally to the shore. The next time you spot conically shaped clouds in the sky, remember it's a good time to start looking for some shelter. If it just stays like that, a severe storm is on the way. But if a cloud of that shape starts spinning around, it means it's about to transform into a tornado. If you have bees nearby, they can save you from big trouble one day. These hard-working little guys get more active than usual when they feel like a storm is on the way. They speed up to collect more nectar before it hits them, and once they're done with it, they'll always come back to the hive 10 to 15 minutes before heavy rain, even when there are no obvious signs of it coming. Their secret is super sensitive hairs on the back, that can pick up electrostatic buildups from storm clouds. For centuries, people have noticed that animals act weirdly a couple of days before big seismic events. Dogs can't stop barking, cows halt their milk, and toads, rats, and snakes leave their homes. It looks like animals can feel smaller initial shock waves that humans don't even notice. Scientists have tried to find some legit explanation for it and run endless tests and experiments. But so far, they're still on their way to explaining this mystery. Can you smell ozone in the air? When a thunderstorm is on the way, it's the most distinct and pungent smell you can pick up. An electrical charge of lightning sets it free from higher altitudes. The other, more pleasant smell of rain is petrichor. Rainwater wakes up molecules on plants, trees, concrete, and asphalt. Their aroma spreads all over the place. You can even feel that smell in your own mouth. All those positive ions in the air that a lightning bolt sets free gets mixed with ozone and your saliva, and that's how you get that bitter metallic taste. When lightning is about to strike, you might hear bizarre crackling, buzzing, or vibrating sounds coming from metal objects nearby. Your palms may begin to sweat, and then you can feel your hair stand on end. That's a clear call for action, and that action is to run for your life. Positive charges are going through your body trying to reach toward the negatively charged part of the storm. Trust me, you don't want these charges to meet. If you see no shelter that you can reach fast, try to make yourself smaller than the objects around you. Drop down your umbrella and stay away from wire fences, metal pipes, rails, and other metallic objects. And don't lie flat on the ground, it's likely wet, which means it's a great conductor of electricity. If you suddenly notice crevices in the asphalt next to your house, it could be a sinkhole warning sign. Inspect your house on the inside. Does that door begin to jam? Or maybe there's a gap where the walls meet the ceiling. Uneven kitchen cabinets and drawers, slanted floors, stairs that begin to slope, water leaking after every rain, and displaced moldings are all signs that a sinkhole is about to open. To find out if it's definitely a sinkhole and how dangerous it is, you gotta consult with an engineering company. If you find a sinkhole that's already there, you gotta stay away from the sinkhole area. Fence or rope it off to make it less dangerous for others. You'll need professional help to fix it. Some volcanoes scream when they're about to erupt. Small earthquakes, which often happen before, produce a hum. It's mostly non-audible to human ears, but sometimes it reaches a frequency that lets you hear it as a strange rumbling or hissing sound coming from the ground. This noise is known as a harmonic tremor. With some volcanoes, it's the sound of magma bubbles vibrating when they're going through crevices in the crust of the earth. But it's not always like this. If scientists manage to understand what exactly causes these volcanic screams, they could create a limited early warning system for volcanic eruptions. If you're out in the wild, pay attention to the water in creeks, streams, and rivers. If its level is quickly falling, even if it's raining, this might be a sign of a nearing landslide. And if you hear a faint rumbling noise or unusual sounds, like boulders knocking together, it could mean debris is on its way to you. It's a sign to head to safety immediately, like right now.
Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have had been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plate thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma-ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon. Summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky. followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit? A solar storm is crashing into Earth like a cosmic tsunami. First, the atmosphere ignites, sparking massive auroras. High-energy radiation slams into the surface, frying power grids, turning lights off across continents, and knocking out satellites. Planes lose navigation, radios go silent, GPS systems crash, radiation levels spike dangerously. Communication collapses, emergency services scramble in the darkness, and chaos spreads as people struggle to cope. Solar particles start to strip away the very air we breathe, slowly peeling off our atmosphere. Soon, Earth will become a harsh and hostile place. That's what solar activity can do to our planet and its inhabitants if we didn't have a protective shield called the magnetosphere. But even with this barrier, we're still in for serious problems. A mysterious 100-year solar cycle may have just restarted, and it could mean decades of dangerous space weather. New research suggests that the unexpected intensity of the ongoing solar maximum may be partly tied to a lesser-known 100-year solar cycle. If the Sun is indeed entering its villain arc, solar activity could spike even further in the coming decades. It means more solar flares, more chances of them messing with satellites, and way more of those crazy northern lights people keep posting on Instagram. Sure, not everyone's buying it. Some space nerds want more proof before jumping on this solar hype train. Let's break it all down into detail first. The Sun goes through a kind of mood swing every 11 years. This is called the solar cycle. It starts off at a solar minimum, which is pretty chill, then slowly gets rowdy. We're talking sunspots, solar flares, and other fiery drama. Once we reach solar maximum, the situation starts to calm down again. The Sun gets sunspots, dark patches on its surface, like the freckles we humans have, when its magnetic field starts flipping out. Literally, the Sun's magnetic field completely flips during peak solar drama. Scientists track how many of these spots show up to measure how spicy the Sun is getting. But wait, plot twist, there are other cycles too, like the Hale cycle, which occurs around every 22 years. This cycle controls how magnetic fields move across the Sun. Plus, way back in history, there were moments when the sun basically went on Do Not Disturb mode. During the Maunder minimum, our star was basically in sleep mode for 70 years. In other words, the sun might be entering a new extra phase, and things could get dramatic. On the bright side, that means more auroras. At the same time, it could also cause issues for satellites, GPS, and other stuff we rely on. Ugh, let's just hope it doesn't mess with YouTube. This extra phase is called the Centennial Gleisberg cycle. It's basically the sun's once every 100 years I do something weird moment. Scientists think it messes with how intense sunspot cycles get. No one has fully worked out how this cycle works yet, but some low-key sloshing of magnetic fields inside the sun might be causing it. Yep, I did say sloshing, like a giant cosmic smoothie. A recent study from March 2025 claims that the CGC might have just hit restart. That could explain why this current solar maximum, the sun's drama phase that started in early 2024, is being so weird and unpredictable. How did researchers figure this out? They looked at something called proton flux. Basically, it's how many positively charged particles are flying around in Earth's radiation belt. There are 2 of these belts, shaped like donuts that wrap around Earth, full of particles from the sun. The thing is, when the sun is active, our upper atmosphere swells, which makes the inner radiation belt lose some of those protons. And when the sun is chill, proton numbers go up again. So those protons have been increasing for like 20 years, but just started to drop in the past year. Which basically screams, CGC has just hit minimum. Time for the sun to crank it back up. The data came from NOAA satellites that flew through the South Atlantic anomaly, which is like the Bermuda Triangle of space. It's this bizarre zone over South America where Earth's magnetic field is weaker and space radiation gets closer to Earth. This area is perfect for observing proton activity without sending a satellite into the actual danger zone. So, right now, we're probably nearing the end of the sun's current chaos phase, aka the peak of solar cycle 25. Back in May 2024, it hit us with one of the craziest geomagnetic storms in 500 years or so. And yes, that means super bright auroras lighting up skies all over the world, even in places that usually only get clouds and vibes. But the scariest thing? This wasn't supposed to happen. During the last cycle, the sun was oddly calm. So NASA and NOAA looked at that and thought that the next solar cycle would probably be the same. No biggie. Well, they were wrong. And they even admitted it. Now, scientists think that SC24's quiet phase was because of the Centennial Gleisberg cycle being at its low point. That probably made it the quietest sunspot cycle in 100 years. So now that SC25 is lit again, pretty literally, it might just mean the sun is back to doing what it normally does, being a little chaotic and wild. Recent studies think the CGC minimum is finally over. That would explain why the current solar activity is turning up the heat, and why the last one felt like a cosmic snooze. An even cooler thing is that a 2024 study used AI to analyze sunspot patterns and found that CGC might be messing with our forecasts more than we thought. And if this long-term mood swing of our star is really back on the rise, future solar cycles could be just as wild as the one we're in now, or even wilder. After all, we've just passed the CGC's low-energy mode, and we won't hit the next maximum for another 40 to 50 years. Around solar cycle 28. That's a few decades away, but the sun's already throwing tantrums. The scariest part is that future solar activity might be twice as intense as what we're seeing now. You might be wondering right now, why should I care? Well, because when the sun freaks out, it messes with our stuff, especially in space. Satellites get dragged out of orbit because Earth's upper atmosphere literally puffs up like a marshmallow in a microwave when solar activity spikes. And this has already happened to a few spacecraft recently. And with tons of private satellite mega constellations like Starlink and its squad, the risk goes way up. There are some, even though those are few, that might not be ready for a full-blown sun rage event. Time to wear SPF 100 for your satellites. Astronauts are also at risk. More solar flares mean more radiation and more danger for humans in orbit. At the same time, more space tourists and missions mean more people potentially in the sun's cosmic splash zone. At the same time, not everyone is buying into the whole CGC is back and ready to party theory. Some experts say it's a cool theory, but we shouldn't get carried away. The thing is, the proton flux, those space particles we've been watching, only started dropping last year. That's not a lot of time. It might just be a short-term dip, like the sun sneezed and now everyone's freaking out. Also, we've only been able to track this stuff properly for 30 to 40 years or so, which is basically nothing in sun time. So there's no solid before and after data to compare CGC cycles and say, yep, this is definitely a pattern. Plus, the CGC itself is kinda mysterious. Like, no one can fully agree on what it even is, how it works, or how much it actually messes with sunspot cycles. It's like the Bigfoot of solar science, blurry, weird, and causing drama in group chats. But even skeptics admit that the new study is interesting and well-intentioned, and that it might help us predict future solar cycles better. We just need more time, more data, and better definition of the CGC before we treat it like the ultimate weather app for the sun.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years, and it does show. See for yourself. Due to such a long isolation, the conditions inside the Movil Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. Two miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7 feet wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under 2 continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed 2 enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges.
The Earth has three main layers: two parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Ah, beautiful! You're walking with your friend and look up at the sky. The sun looks a bit different today, like it has some kind of ring around it, a rainbow type thing. Huh? Hey, look at that! Your friend pulls his head up out of his phone. You shouldn't look directly into the… Stop everything, he says. It's a sun halo. We need to find shelter now, unless you have the world's biggest umbrella on you. A sun's halo is nature's sign that there's a snow or rainstorm on its way. It's caused by clouds that are made of bazillions of small ice crystals flying around 20,000 feet. Sunlight goes through those crystals, which causes the light to split and refract, like when there's a rainbow. Now, don't look at the sun halo directly. It's going to be tempting because it's not something you see every day. Plus, it's really beautiful. But ultraviolet light can burn the exposed tissue of your retina and cause serious damage. So, not worth it. Grab some sunglasses and you're good to go. This phenomenon lasts about 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many ways. J-shaped trees means there's a landslide coming. Since the ground is moving slowly, the trees grow into the super selfiable shape. Try to find a flat area and avoid going near any trees, unless you have superhuman strength. You're on a nice walk on the beach. Sand, sun, not a cloud in the sky. Then, out of nowhere, you see the ocean going back away from the shore. Suddenly, you can even see bits of coral, small fish, and other random small sea animals. That's a good sign to leave. There might be a tsunami on the way. A tsunami is formed when there's an earthquake underwater, and it can hit the coast at 500 miles per hour. It's mostly a Pacific Ocean thing, but why risk it? If there's a channel of choppy water on the beach, stay away. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange gap in the waves, or you might notice random bits of seaweed going in all different directions. If you don't ever find yourself caught in a rip current, try to stay afloat and don't waste your energy swimming against the current. Yell out for help and try to float your way along the beach. Once you break out of the channel, swim diagonally to the shore. If you find yourself in the ocean and see a group of sharks swimming, okay, this scenario doesn't sound good either way. Well, the good news is they're not necessarily coming for you. The bad news? The sharks might be trying to escape from a huge tropical storm or even a hurricane. Sharks can sense these things, so when nature gets angry, they group together and swim deep under the surface to get to safety. You probably shouldn't follow them. Good luck! The golden rule since ancient times: follow the animals. Insects, rats, and snakes leave their homes a couple of days before really big earthquakes. Scientists can't track or really explain how they know it's coming. It seems animals really can sense earthquakes, maybe because they feel those smaller initial shock waves that we don't even notice. What if you see animals running towards you? Well, that could mean you're about to get eaten for breakfast. Or it means there's a wildfire behind them. Amphibians like frogs, toads, and salamanders try to protect themselves by burrowing down into the ground. Others just run. Before you start running alongside them, check to see if you can see smoke. You don't want to sprint flat out for nothing. Well, it's not just animals. We can spot warning signs too. For example, if you notice your hair suddenly starts to stand on end and your jewelry starts to buzz, take shelter right away. Lightning might be about to strike somewhere nearby. If you're outside and can't run into a house, make sure not to stand near any tall structures. Lie flat on the ground. Be near water. Seek shelter under an isolated tree or stand in an open space. And don't stand on top of the Empire State Building. That thing gets zapped hundreds of times a year. Do you like skiing? It's all fun and games until all you can see is white. Avalanches can move up to 80 miles an hour, so watch for some warning signs. Does it feel hollow when you walk on the snow? Are there cracks around your feet? Can you see a huge avalanche coming? Time to go! Sometimes a storm mixes its blue light with the red light from the sun, and you get a pretty impressive green. Enjoy it from a safe distance, preferably indoors. This super tall thundercloud usually means you're about to get smashed by hail, or worse, a tornado. Find cover somewhere, like in an underground parking lot or a basement. It might be a bit embarrassing if you're wrong, though. Okay, we know volcanoes can be dangerous, but the lakes near them? Is anything not a sign of danger? Lakes that are near something boiling hot that never cools, so volcanoes, are like wildly shaken soda cans, just about to burst. The magma that's underground actually pushes carbon dioxide into the bottom of the lake, and that gas stays there, waiting. Then, even something boring like rain can disturb the lake a little too much and bam, or boom! You get the picture. Diving, swimming, snorkeling, the sea can be amazing, but it's pretty unpredictable. When two wave currents run into each other, they can create a cross sea. It looks pretty cool from far away, but it can be really dangerous for swimmers, surfers, or even ships. There's a strong current roaming around under the surface. You're walking on the beach, apparently every good story starts like this, and all of a sudden, woo, a cave. How cool is this? You should probably go in there, explore a bit, and no. If there's a full moon out, you might not be able to get out of that cave. A full moon affects the tide and makes it lower than usual. That cave might be more accessible, but instead of an exciting adventure, you could end up trapped in there until the next full moon. Bring a big lunch. A wall cloud is one of those things you're both excited and scared to see. Scared because you don't know what it is. Excited because, well, how often do you see something like that? Whatever you feel, tell your legs to start running. During a thunderstorm, these wall clouds sit lower than anything else and can be up to 5 miles long. And if they start spinning, well, Dorothy ended up in Oz. Who knows where you'll end up? It's 2009 in Italy. A man was hanging out in his kitchen. Then he saw some flickering lights. He knew just what to do. He moved his family to a safe place. A couple of seconds later, a massive earthquake hit the whole region. His family survived thanks to his quick reaction. He knew these flickering lights were actually a sign of an upcoming earthquake. People have been seeing these mysterious lights for ages. Some thought it was some kind of sign coming from space. Scientists never used to take them seriously, but after the invention of photography, more and more evidence of these strange lights appeared. Soon, they realized the connection. The lights appear, and pretty soon, the earthquake hits. After a bit of digging around, they actually found some records of these earthquake lights from hundreds of years ago. There were bluish flames coming out of the ground right before an earthquake. Ooh, creepy. Oh, ocean, come on, not you again. Okay, but just one more. If you see the oceans turned all reddish-brown, don't go in the water or anywhere near it. This red tide is caused by toxic algae and is something you can find all over the world. That toxic algae can be there even if the ocean's a normal color. Getting that stuff all over you can cause some health issues. Rinse yourself off in fresh water as fast as you can. You know, they even wrote a holiday song about it. Algae Home for Christmas. No, really.
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, plop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are 2 stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These 2 aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun. So its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun, and if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny!
Around 5.3 million years ago, a crucial event reshaped the Mediterranean region. It was a colossal flood that refilled the local sea, which had been extremely barren and salty up until that point. It got the name Sunglint flood, and it forever changed the geography of the area. The Mediterranean Sea is surrounded by Europe, Africa, and Asia, and connects to the ocean by the Strait of Gibraltar. This is quite a narrow passage, measuring about 8 miles. It may not be that wide, but the strait plays a crucial role in maintaining the liquid balance between these two bodies of water. About 6 million years ago, a bunch of things might have caused the Mediterranean to be cut off from the Atlantic Ocean. Some say it was an ice age. Others speak of tectonic movements, like earthquakes. Whatever the cause, it pushed the Mediterranean area into a period called the Mycenaean Salinity Crisis. For about 1,000 years, the sea slowly evaporated, leaving behind a dry basin that was several miles below sea level. This crisis really changed the landscape, creating conditions similar to those found in today's Dead Sea. What this means is that the lush Mediterranean beauty used to be a super salty environment, containing nearly 10 times more salt than the ocean. Say you could have visited. You would have been able to effortlessly float on the little water you could find, even if you're not a skilled swimmer. The amount of salt and that mineral content would have made it challenging for most creatures to survive. However, some hardy microorganisms, such as bacteria, could have adapted to these harsh conditions. These days, at the bottom of the Mediterranean Sea, we can find holes as large as the Grand Canyon, and they seem to have formed during that same period of dehydration. Evidence suggests that massive rivers, such as the Nile and the Rhone, flowed directly into the Mediterranean back then, leaving behind canyons as they reached the bottom, thousands of feet below the sea level. People had to find some sort of explanation back in the day for the drying of the Mediterranean, so they came up with myths and legends. One such tale was told by the people of southern Iberia, in modern-day Spain and Portugal. It was also recounted by a famous Roman writer called Pliny the Elder. What this legend said was that the Mediterranean used to be cut out from the ocean until the hero Hercules, with his mighty sword, carved a path. He did so between a fictional location in modern-day Africa and the Rock of Gibraltar. This allowed the ocean waters to flow in, transforming the Mediterranean into what we know today. Some fossils also seem to confirm the unusually large flood. Remains of marine organisms were found in layers high above current sea levels. This means the areas were once submerged underwater. These fossils belong to mollusks, fish, and marine mammals. Because of modern techniques, we now have at least an estimated timing of the Zanclean flood. Scientists used computer simulations to reconstruct the event, providing further evidence that it was real. What they also discovered is that there's a possibility the Mediterranean might change once more. The Strait of Gibraltar could close, most likely because of movements deep under the ground. This could lead to the Mediterranean becoming dry again, over a span of about 1,000 years. The Mediterranean area could disappear altogether if the African continent keeps shifting north too, getting closer to Europe. Another one of those famous yet still a bit hypothetical large floods is called the Black Sea Deluge theory. Some scientists think that around 8,400 years ago, water from the Mediterranean might have spilled over into the Black Sea through a narrow passage called the Bosporus Strait. This could have caused a massive disaster, forcing people living near the Black Sea to pack up their things and move further inside the continent in both Europe and Asia. Along with them, they might have carried stories about this colossal flood. The specialist that came up with this idea also suggested that these migrating people might have brought along new ways of farming. Not everyone from the scientific community is convinced though. Some argue that while there might have been a flood, it likely happened earlier and was way smaller. They didn't think this flood could have caused, for example, the story of Noah's Ark. In this legend, a spiritual man was warned by a higher entity that a giant flood was on its way. The man went to gather pairs of animals and pack them all in a boat to make sure these species would survive the devastating flood. There was also the concern among scholars that discussing real floods and ancient stories too much might blur the lines between science and fiction. There may be other reasons why these flood stories are so often found across different cultures all over our planet. One idea is that floods were incredibly destructive for early farmers, so they invented myths about them signaling the end of the world. Another idea is that people stumbled upon ancient sea creature fossils in unusual places, leading them to believe there was a significant flood in the past. The solution to future floods, though, might be floating cities. As sea levels continue to rise, coastal cities like Amsterdam, New Orleans, and Venice may go under. So, floating infrastructure may be the way to go, with buildings that can rise with the water levels, making them able to resist extreme weather too. Countries like the Netherlands, which have a history of managing water risks, are pioneering these floating creations. With cities running out of space for expansion, we might be forced to move on water anyway. By moving on the water, we can reduce crowding and create more interesting ways to feed ourselves, like floating gardens. These homes also come with great alternatives to our energy needs through systems that use solar and wind power. Not to mention that these homes might turn out to be cheaper in the long run. One such floating city might pop up soon in the Maldives. Its goal is to host up to 20,000 people and will feature places to live and eat, but also shops and schools. Designed to look like coral, the region will include canals placed between some 5,000 floating pieces of land. The city will be constructed using modular units, put together in a construction site nearby. After they're completed, they'll be towed to the floating city. The next step is to secure them to a large underwater concrete hull, which is screwed tightly to the seabed on some steel stilts. All these pieces of construction let the modular units easily move as naturally as the sea. Even for those that are afraid of seasickness, there's a solution. That's what the nearby coral reef is for. It will surround the city, making a natural wave breaker. Human-made coral banks will also be placed underneath the city, which will also help coral grow naturally. The long-term goal is to make the establishment self-sufficient. It will have electricity, mostly from on-site solar power. Waste will be treated nearby and reused as plant fertilizer. Instead of air conditioning, the city will use deep-sea water cooling. This method pumps cold water from the deep sea to cool the area, saving energy. Earth is not the only planet that's seen some serious floods. In ancient times, Mars seems to have experienced them too, and they played an important role in shaping its surface. Recent research reveals that billions of years ago, Mars was heavily affected by some serious river flooding, which contributed to the formation of its valleys and canyons. The reason for these floods was heavy rainfall, which reshaped the Martian landscape in a jiffy, at times even within days or weeks. Unlike Earth, where rivers form pretty slowly, Mars experienced rapid changes because of these floods, particularly around 4 billion years ago. We've known for quite some time that there have been floods on Mars, but this study really showed us their extent. We now know they were more widespread and frequent than previously thought.
Doggerland? No, it's not a country of dogs, as you probably first thought. It's a land the size of Great Britain in the north of Europe. But don't bother trying to find it on the map of the old continent. Your search will come back empty. Doggerland hasn't existed for thousands of years. But where was it exactly? And did humans live here? Scientists are doing their best to answer these questions. Let's start with the name. In the 1990s, a British archaeologist named the area Doggerland after Dogger Bank, a sandbank some 60 miles off the east coast of England. The word probably comes from Dutch. It was used for a fishing boat with 2 masts. Makes sense, since today, the North Sea is a rich fishing area. But thousands of years ago, people living here had a different diet. Some 12,000 years ago, the last major ice age was slowly reaching its end. Doggerland didn't feature seawater, but marshlands, lagoons, forests, and gently sloping hills. At that time, Britain and Ireland weren't islands. They sat deep inland. You could set off in Denmark and walk all the way to the north of Scotland. There was a system of rivers that emptied themselves in the North Sea. Back then, it was more of a channel that separated Doggerland from Norway. The rivers were different too. The Thames flowed into the Rhine. The ancient river they formed flowed into the place of today's English Channel and emptied itself into the Atlantic Ocean. Doggerland even featured a lake. There were some glaciers as well, but the land was still inhabitable. So who lived there? There were communities of hunter-gatherers from the Middle Stone Age. This was the time of human history when our ancestors mastered chipped stone tools. They used these stones with sharp edges for spears and arrowheads. This came in handy at Doggerland, which was the richest hunting area in all of Europe. It could have easily been the most populated region in the northwestern part of the continent. The hunters' prey likely consisted of reindeer, mammoths, oxen, wild pigs, brown bears, wolves, and many other species. In short, nobody went hungry here. Meat wasn't the only thing on the menu. Ancient residents of Doggerland collected hazelnuts and berries. They lived in wooden huts. They built them close to rivers, and they even constructed their settlements on hills. Remember Dogger Bank? It now sits underwater, but it used to be a mountainous region. Doggerland must have been prime real estate in prehistoric times. Its total surface area was over 18,000 miles, but things were about to go under, literally. The last ice age was ending. All the water trapped in glaciers and ice sheets started to melt. You experience this process firsthand every time you order a cold drink. Even if you drink it bottoms up, after a while, the glass is full again. Why? Because the ice cubes have melted. Think of Doggerland as that glass. The sea levels started rising quickly. Every century, the sea flooded from 3 to 6 feet of dry land. Just imagine what this would mean today. Miami's elevation is just over 6 feet. The city would be flooded in less than 100 years. But there was one event that speeded things up. The Storegga slides were a series of submarine landslides in the Norwegian Sea thousands of years ago. And what happens when huge chunks of Earth shift suddenly underwater? Gigantic waves. You probably know what a tsunami is. Doggerland was likely pounded by several of them. They were so powerful that researchers believe they washed away Great Britain's land bridge to the rest of the continent. All that was left of Doggerland was an island the size of Wales. Scientists estimate that the waves of this ancient tsunami were at least 40 feet high. Some 6,000 years ago, Doggerlanders were on the move. They were migrating to higher grounds, England and the Netherlands in their case. The ironic part is that when we literally translate the name of the country of Netherlands into English, we get lower lands. But thousands of years ago, this was higher ground for hunter-gatherers escaping the flood. Once it was all over, the continent of Europe got the shape we easily recognize today. But Doggerland was nowhere to be seen. It's been sitting under the waves of the North Sea for 8,200 years. Does the idea of Doggerland remind you of a more famous case of a submerged land? The lost city of Atlantis comes straight to mind. But there is an important difference. Atlantis is only a legend. Everything we know about it comes from the writings of the Greek philosopher Plato. Scientists have been searching for Atlantis for a long time. And, up to this day, they can't even agree where exactly it was. Theories range from the Mediterranean to even Antarctica. Doggerland is not a myth. Everything science knows about this lost land comes from hard evidence. In 1931, a fishing boat was doing its thing off the coast of Norfolk in England. At the time, the crew would drag a net along the sea floor, sweeping everything in its path. And they caught something more than fish. It was peat, like the stuff we find in Alaska and in Ireland. But what was it doing at the bottom of the North Sea? It didn't belong there, because seawater destroys peat. There was only one possible explanation. The area must have been dry land at some point in history. The final proof was that the peat contained a harpoon spear point, a sure sign of human activity. The idea wasn't new, though. Since the Middle Ages, there has been talk of submerged land with underwater forests. In 1913, a British geologist came forward with the idea of an undersea world in this part of Europe. Scientific evidence kept piling up. Local fishermen started pulling out human-made tools and animal bones. Researchers dated them to be around 9,000 years old. But the deep, murky waters of the North Sea made it impossible to send down divers. One archaeologist noted that they knew more about the surface of the moon than what lay at the bottom of this relatively shallow sea. The discovery of oil in the area in the 1960s was a real game changer. Companies from the industry provided seismic survey data to scientists. This helped them piece together the full image of what Doggerland used to look like. Computer models soon produced images of river valleys, coastlines, freshwater lakes, and hills. There are even footprints of nomadic tribes preserved on the sea floor. Today, marine biologists are using magnetic fields to map out this lost underwater world. But Doggerland isn't the only place on Earth that went under the waves. Beringia is another lost world of global importance. This used to be a land bridge between Asia and North America. It got its name from the Bering Strait. It is 53 miles wide at its narrowest point. But until the end of the last ice age, this was dry land that our human ancestors called home. Genetic evidence shows that Native Americans lived in Beringia for some 15,000 years. If you want to imagine what this land looked like, think of present-day Arctic Alaska. It was a shrub tundra. There were also small willows and birches. Sorry, no woolly mammoths. Large grazing animals simply wouldn't have had enough food in Beringia, though there were probably elk and bighorn sheep in the area. But the Ice Age wouldn't last forever. Like in Doggerland, sea levels started to rise. This happened some 13,000 years ago. It wasn't all bad news, though. Scientific evidence suggests that around this time, people started moving south. They left the slowly sinking Beringia and crossed over into Alaska. From there, they populated both Americas. These were the ancestors of Native American tribes.